Okay, so let's first look at what are non-polygons. Tell me some characteristics that you guys know would make something not a polygon. Fletcher.
There's 3 sides.
A polygon can have 3 sides.
Or I mean if it's not closed.
If it's not closed. So I think what he's saying is if it has less than 3 sides, right? So when he says not closed, he means something like if you have 2 sides, are you ever going to be able to close that figure? So you need at least how many sides? At least 3 sides. Now you can have a figure that has more than 3 sides that still doesn't close. So you might have something that looks like this, and that still would not be a polygon because it does not close. All right, what's something else about a polygon that, or something else that would make a figure not be a polygon? Bree?
Can they not be like round?
They cannot be round. So even if you have, oh, thank you, sorry. Okay, so yeah, you cannot have a rounded edge. So what I was saying was even if you have a couple of, or a few edges that are straight, all that it takes is one edge to be rounded. Whoop, that doesn't look very good, does it? Let's try that again. All that it takes is one edge to be rounded to make it not be a polygon. Can anyone think of anything else that would make something be not a polygon? Ty, can you take your earbud out? Thank you. There's a couple more things that could happen. If they cross, very good. So if you have something that looks like this, where it intersects on itself, that would also not be a polygon. There's one last thing that you would want to watch out for, something like this, okay? In this case, it's closed. It's not technically crossing in on itself, but you've got this edge that is not a part of the overall shape. That would also not be a polygon. Are there any questions about the types of things that would make a figure not be a polygon? No? Okay, so let's then be able to draw some polygons. Can anyone tell me how I would draw a 3-sided polygon? Just a triangle, right? Okay. How about a 5-sided polygon? A rhombus has 4 sides. What? A pentagon, right? So you can have a pentagon. Now notice that I'm kind of drawing this pentagon to be sort of birdhouse shaped. Does it have to have that kind of circular look to it, or can you kind of jut in on itself? In other words, could I draw a pentagon to look like this and still have it count as a polygon? Yes, that is okay. You can have a polygon that sort of caves in on itself as long as it doesn't cross lines, intersect any of the sides, okay? All right, are there any questions on what constitutes as a polygon and what constitutes as not a polygon? No? How about this one? This one's going to be kind of, if I can draw it well. Is this a polygon? Yes, it is. You can see that it's closed the whole way around. It never intersects over itself. Doesn't have any rounded edges, so it's a goofy polygon, but it is a polygon. All right. Okay, so at this point, you should be able to identify whether or not something's a polygon. Now what we want to be able to do is name our polygon based on the number of sides it has. All right. All right, so we're going to identify your shapes based on the number of sides that it has and then give it a name. So what was the minimal number of sides that we talked about earlier? Yeah, so the minimal number of sides that you can have is 3. What is the name of a 3-sided polygon? Triangle. Very good. Okay, how about a four-sided figure? I can draw a four-sided figure that's not a square or rectangle.
Quadrilateral.
Very good. Yeah, you want to give it the most general name possible. So the most general name here is a quadrilateral. How about a five-sided figure? Five-sided?
Is that a
Somebody said it earlier. Pentagon. Very good. How about a six-sided figure? Hexagon, yep. Here's going to be kind of the new one for you guys. How about a seven-sided figure? A what? Very good. Heptagon. Eight-sided? Octagon. Nine. Anyone know a nine-sided? Somebody in my last class said niftagon. I thought that was pretty clever, but it's not. It's a nonagon. Ten-sided. A what? Decagon. Very good. All right. How about an 11-sided figure? Any thoughts?
could it be
I just wanted to see what you guys would come up with. There is no name. So what we do is we write 11-gone. Sorry.
I got for like 11 or not.
Almost. 12 does have a special name. 12 is kind of hanging in there. Does anyone know what the 12-sided is? Dodecagon. Very good. And then from anything 12 and up, or 13 and up, you would do, so like 13 would be a 13-gon, just like the 11. And then from there, any n-sided figure, so if you have anything higher, 25, 100, 1,000, whatever, you're going to write n-gon. So filling in n is the number of sides. So in other words, if you have 24 sides, you will write 24-gon, just like the 11-gon. Okay? All right, for this list here, I am going to be giving you guys a speed quiz over this next Wednesday, so you have over a week. Most of these names you guys already knew. The ones that some people aren't as familiar with would be heptagon, might be new for some of us, and then nonagon, decagon, and dodecagon might be new for some of us. I heard, it sounds like you guys already know those. On the quiz, what will happen is you'll get a chart, and it will have the two columns, so a number of sides columns and a names column. It will be scrambled in the sense that it will not be in numerical order like this, and I will have missing blanks on either side of the chart. So in other words, I might at some point in the chart over here, whoa, I thought I had my pointer, sorry. I might have the word nonagon over here, and then a blank space over here, so you would have to know that a nonagon has 9 sides. Vice versa, in the chart, I might have somewhere like 5 sides and then a blank space over here, and you would have to know that a 5-sided figure is called a pentagon. Spelling will count. That's probably what will get most of you, okay? Make sure you can spell them as well. So I would maybe do some note cards. All right? That will be next Wednesday, though. You've got some time. It will be speed, so it will be timed. I'm not going to let you sit there and ponder it all day, okay? Just be ready to do that. Okay, so at this point we can now look at a figure, determine if it's a polygon, and if it's a polygon we can give it a name, right? So the next thing that we have to be able to do is decide if something is concave or convex. I used those words earlier today. So we've got the terminology, like I said, concave versus convex. We need to know what that means. All right, now there's a few different definitions. I'll teach you kind of multiple ways that you can think about this concave versus convex business. All right, let me just draw up here a concave figure. So something that is concave is this guy right here. The formal definition of concave, and let me draw a convex figure so we can see the difference. Something that is concave versus convex. You can kind of think about it as a concave figure caves in on itself. Okay, and then kind of another non-mathematical way to think about it with that caving in business is if you took that figure and you asked yourself, can I rotate that figure such that, oh, is it showing up on your screen yet? All right, well, just wait a second. I wonder why it's not showing up. But I'm rotating the figure. I'm going to say done here in a second. So can you take that figure and rotate it so that it could hold water if you were to put water in it? So if you look at this guy, I have flipped the figure around, and I could now fill this part with water, and it would hold. Right? Is there any way on this figure that you can flip it so that it could hold water? No. So that's kind of a non-math. No, you cannot balance the water. Even if it's a perfectly flat surface, we will assume that the water will not pool up in it, right? So the question is, can you flip it so that you could hold a pool of water? That would make it concave. Do you have a cave that you could hold water in? Okay? That's kind of a non-mathematical way to think about it. Some of you are going to prefer that way. The other way that you can think about it is if I were to extend my sides, if there's any of the sides that would go into the interior of the figure, that would make it concave. So in other words, if you look at the convex figure, if I extend all of my edges, do any of those extensions ever go inside of the figure? No. Okay, let's take a look at this one. Now these two don't extend inside of the figure, but you do have these two which do extend inside of the figure, right? So if they do this business where they cross into the interior, that makes it concave. So some of you might like this method better, just to extend all of the sides and see like, okay, if any of my sides go inside of the figure, that makes it concave. If they don't, then it's convex. Some of you are just going to prefer to look at the figure and ask, okay, if I flip this around, is there any way that I could get the shape to hold water? Right? Are there any questions on what concave versus convex is? No? So the next thing that we need to talk about is, can you identify a figure as being equiangular? Which you guys already know what that means. We've done that in triangles. Equilateral. Whoa. Or our new word is regular. Now it could be one of these three things or none of them. Okay? Equiangular means what? The angles are equal, right? So can anyone think of a figure that would be equiangular but not equilateral? A square is equilateral. A rectangle, sure. So something that's equiangular might be a rectangle.
What about a trapezoid?
A trapezoid is not equiangular because it would have two obtuse angles on the bottom and or vice versa, two acute angles on top. All right, so for this one, you'll notice that we get our, we have all four right angles So it is equiangular. The problem is that we do not get equal sides because these guys are shorter than these guys. So that's something that you would name equiangular. How about something that you could name as being equilateral but not equiangular? Anyone come up with a shape to do that? Equilateral, not equiangular. No, because a triangle that has equiangulars is forced to be equilateral. Think of a four-sided figure that has equal sides but that is not equiangles. A rhombus. Jeez. Yeah, a rhombus. Very good. Trying my best to draw this. So my drawings aren't very accurate, but you got it. So we're assuming that all of the sides are the same length, but you'll notice that between the angles, you've got these two acute angles, and then you've got two obtuse. So not all of the angles are the same. All right. Something that is regular is both equilateral and equiangular, which in a case of four-sided, yep, that would be a square. So if something is both equilateral and equiangular, we are now, rather than using those two long words, we are now going to describe an equilateral and equiangular figure as regular. So at this point now we get all four angles are the same and all four sides are the same. And you could have none of these, right? You could have a figure that doesn't have any equal sides or angles, which is fine. Any questions on that? Does everyone think that they can identify if a figure is a polygon, if what its name is, if it's concave, convex, and if it's equilateral, equiangular, or regular? Think you can do that? If you think so, I'm going to test you on it. All right. I'm going to draw some figures up here, and I want you to tell me if they are a polygon, what its name is, if so, concave or convex, and then...
Wait, is this going to be on the test Thursday?
No. No. This stuff will be on the next quest.
So what if once on Thursday it's just going to be the golf?
Alrighty. So let's do this figure really quickly. Whoa, I meant to have this guy. Okay, is this a polygon?
Yeah.
What kind of a polygon is it, name-wise? Pentagon. 5 sides, pentagon. Is it concave or convex? Convex, yep. There's no cave that could hold water, right? And is it equilateral, equiangular, regular, or none? Equiangular. If I did not mark the sides, can you assume that they are equal? No. All right. So there's one. Let's try another one. Polygon? No. Can you explain why? Because it has an edge that is not closed in with the rest of the figure. Not a polygon. So if it's not a polygon, am I really going to talk about the rest of it? No, right? Okay, let's try another one. All right. All right. Is it a polygon? Yes. What kind of a polygon? Careful. Yeah, it's a decagon. If you count the number of sides, it does have 10 sides. Okay, so a 10-sided figure is a decagon. Is it concave or convex? Good. Is it equiangular, equilateral, regular, or none? Equilateral only. Yep, you don't have equal angles. If you look up at the figure, where's my arrow? Do you guys see it? There it is. Okay. You've got some acute angles, but then you also have these big obtuse angles, right? So even if all of the acutes are the same and all of the obtuses are the same, you have two different measures going on. So this is only equilateral, and it's only equilateral because I've shown you that the sides are equal with tick marks, right? If I haven't indicated it, you don't want to assume it. All right, let's take a look at another one. Is that a polygon?
Yes.
Yep. What kind of a polygon is it? Octagon with 8 sides. Good. Concave or convex? Do you have a cave that you can hold water on? Yep. So convex because there is no cave on that. Equilateral, equiangular, regular, or none?
Regular.
Regular. Okay, let's do one more and then we'll call it good. So for this one, let's just do I want to do that one? Yeah. Kind of looks like the second one we did. Is it a polygon? Yes. What kind of a polygon? Good. 4 sides, so it's a quadrilateral. Concave or convex? Do you have a cave that can hold water? Okay. Is it regular, equilateral, equiangular, or none? None of the above, so nothing. That's it. Any questions on all of those identifications? Okay. I've got a couple more things to go over. All right, so for starters, tell me what do all of the interior angles of a triangle add up to? 180. Okay, we're going to be able to do the same thing with any polygon now, coming up soon. Today we're just going to talk about quadrilaterals though. So does anyone know what all of the angles in a quadrilateral add up to? 360. Very good. So if I give you a problem that looks like this, let's do... Okay, give me 1 second. So let's say that this angle measure right here is 76 degrees. This angle up here we'll say is 145 degrees. This angle I'm going to make that symbol. And I want you to find this angle. How are you going to find that angle based on what we just talked about? What does the sum add up to? 360, right? So you can do this a couple of different ways. You can add up the three angles that you know and then subtract it from 360, or you can just take 360 and subtract off each angle at a time. Doesn't really matter. So I would take 360 minus 145 minus 90, because that's what that little square means, and then minus 76. That will find my last angle. Can anyone calculate that for me? 41? Bree, do you have a question?
Yeah, you said like in quadrilaterals only, well, like so far we know only quadrilaterals
Yeah.
add up to 360,
Yeah.
right?
So a pentagon will have something different, but we won't look at that today.
Okay.
What did you guys say? 40 what? 9? Okay. So that would be this last angle measure. Are there any questions on how to do that type of a problem? All right, I can do this angle measure business one other way. Well, more than one other way, but kind of the most common other way is for me to, rather than give you a figure and give you the actual angle measures, I could write it verbally, and I could introduce variables instead of giving you the exact measurements all the way around. Okay? So what that might look like, and this is our last example, what that might look like is, and let me, okay. So let's say that a quadrilateral has two right angles one of the remaining angles is 3 times the measure of the last angle. And what I want you to do is find the measure of all 4 angles. Anyone have any ideas on how we're going to do this? Shouldn't be too difficult. What do you know? You're given information about all 4 angles, right? What do you know about all 4 of them? They're going to add up to 360, so we need to start adding them up. What are the 2 easiest angles that you can add together? 90 and 90, because you're given 2 right angles, right? So I would start by writing 90 plus 90, and now I need to come up with a way to add in the other 2 angles that I don't know the exact measure of. What can I do to signify those angles in their relationship and add them in? I can use x for one of the angles because I don't know what it is. And if one of the angles is x, then the other one is 3x, because I've told you that one angle is 3 times the other, right? And then all 4 of those should add up to 360. All right, so now you've just got a few steps of math to go through. So 90 plus 90 is 180. X plus 3x is 4x. If I subtract the 180 off of each side, you'll get 4x equals 180. And then divide 180 by 4, what do you get? Yep. Now am I done? Am I done? No, because I asked you to specifically list out all of the angle measures. So I can just come up, what are your two of your angle measures? You've got a 90-degree angle and a 90-degree angle. What's another angle measure that you found? 45 is one of them. And then the last one? What is it? Right, 135, because it should be 3 times the 45-degree angle. Any questions on that? All right, so we're done.